Okay.
Thank you, everyone, for joining us this evening. My name is Aurelio Muraca. On behalf of the Friends of the Danbury Library, we welcome you to part 3 of our series, Earth in Crisis. And tonight we'll be talking about stronger storms and rising seas and some ice with Dr. Mitch Wagener of the Department of Biology and Environmental Sciences at Western Connecticut State University. So with no further ado, Dr. Mitch, this is your time.
All right. Let me push the right buttons. And can you see my standard start slide with the science building in it?
Yes, we can.
All right. That goes good. I have a little bit of allergies and I have a wad of tissue. If I cough, I'll cough into that, I hope. So I won't break anybody's ears, let's hope. All right. So those of you who don't know me and haven't seen other talks of mine, this is the science building at Western Connecticut State University Midtown campus, not too far, just a few blocks from the Danbury Library. And this is my standard start. Okay, where am I? Okay, there we go. Now, we're talking about stronger storms and rising seas, but really I should have added a third term, and that is melting ice, because that's all part of the story as well. If you've seen my talks before, I often start or early on show this diagram, which is showing a handful, a representative collection of those effects of climate change that we're able to measure. In fact, they're being measured by, hosts of scientists and proto scientists, grad students and so on around the world. And the data is collected and conclusions mapped out, and the conclusions are published and submitted for peer review to make sure that the authors didn't make some terrible mistake. Anyway, the point here is the climate change is a very diverse set of factors that are changing, including some of which are in the atmosphere, like heat and humidity in the atmosphere, and some of it is a matter of ice melting. As I said before, and I'll say again, the thermometer of the Earth is the ice, and if the world were not warming, ice would not be melting year after year after year. And there's also biological effects of climate change, and there's a bunch of new ones that are papers that are just recently out about timing of birds migration and timing of flower blooming and all sorts of stuff being earlier than expected. Okay, one of the ones we're going to talk about today is the one on the bottom, says ocean heat content. All right, now a couple of years ago, a review paper, as scientists call them, came out basically taking some of these factors and some other factors and finding data and summarizing the data, showing the effect, and not in terms of just an arrow, but in terms of data points and regression lines and all that jazz. And so we're going to be focusing on, if you look at the top right corner, we have surface temperatures. We're going to be focusing on that. We're going to be focusing on E, which is minimum Arctic sea ice, Greenland ice mass, Antarctic ice mass, and ocean heat content. All right. The rest of the stuff, and sea level change, the rest of the stuff is all part of the package. You cannot have, one without the rest. Okay, because they're all connected. As Margaret Atwood says, climate change is everything change, and it is. But we're all going to focus on one particular story, which is heat and storms and ice melt and sea level rise. Well, 2021, I'm born in the wrong century. I said 19 something. 2021, just the most recent complete year of data shows that those areas which are warmer for that year than the 1951 and 1980 average, okay, are shown in red, and those in blue are those that are cooler than that average. Okay, every year it's a little different arrangement of oranges and yellows and blue. Generally speaking, we see very little blue. Now, we see a little bit of blue in the 2021 data because it was a La Nina year, at least part of the time. And if you look at the ocean to the west of Peru and Chile, you see a blue patch, and that is what is indicative of La Nina. Well, anyway, the other thing I wanted to show you, although it's harder to see in 2021, but there's a patch of light, which is often blue, south of Greenland. It's called the blue blob. Really, that's what it's called. And it is cold water resulting from all the ice melt on Greenland. And it has some fairly significant effects that we'll talk about. All right, let's talk about cyclonic storms first. A cyclone is a storm that spins around in a circle, okay? When you think of cyclones, you think of, well, if you grew up in Kansas, you think of tornadoes because that's what they called the tornado in the Wizard of Oz, okay? Cyclones are also what they call hurricanes in the Pacific Basin and the Indian Ocean, or at least part of it. And it's a hurricane to us on the East Coast. And hurricanes are these big storms that spin. They spin, the direction of the spin is caused by the Coriolis effect, the spin of the Earth. And so that the spin will be different in the Northern Hemisphere than it is in the Southern Hemisphere, if they're far enough away from the equator. And the cyclonic storms are, the hurricanes are storms that are fueled by heat. The hotter the water, the stronger the storm, okay? And they all have this beautiful, you have to call it beautiful, beautiful shape with the, you know, the little spin, the little arms there, and you've got the little hole in the center, which is the eye. And they're not beautiful if you're on the ground and trying to survive one, but they're beautiful from space. And basically, I'm not going to go through the whole deal, but they are centered around a low pressure system, a really intense low pressure system. Okay, the barometric pressure in that middle of that eye is low relative to around the storm, and that forms, and that is the axis of the spin of the storm. And Lydia, who's in the audience and who is a meteorologist, can correct me, but I'm not going to get in too far out in the weeds on all this. And so they look like this. I mean, they look like the finger of God, but they also look like gorgeous things. Well, one of the things about a storm is that all that wind pushes against the surface of the water and tends to act like a bulldozer and push that water up on land. But there's also, since the eye of the storm is such low pressure, it causes some of the surface water to kind of get sucked up a little bit. And that's the pressure surge in addition to the wind-driven surge. And together they will produce this big pile of water. That's a technical term, big pile of water that they are moving whichever way they're going. Now, when they hit land, oh, and by the way, generally speaking, the longer they're on over warm water, the stronger they get, unless there is some other thing that are tearing them apart, okay? Well, anyway, I'm an ecologist, not a meteorologist, but if the water is pushed by the wind and reaches land, it tends to push up over the current level of tide and form what's called a storm surge. which is an extra bunch of flooding in an area in excess of what they would ordinarily see outside of a storm. And so one of the big things that causes damage with a hurricane is the wind, but another big thing is the flooding. Now, hurricanes, whatever they happen to be called at a given place, typhoons or cyclones or whatever, are found in the not right at the equator, but a little bit north, a little bit south, in both the east and west hemispheres. And you see that those storms, the storm tracks of the strongest storms, are shown in red, and the weaker are shown in yellow. And you can see there's an awful lot more red in the Pacific. That's because the ocean is wider there, and those storms can track a longer time over warm water and pick up a great lot of energy. Okay. Now, what's this all got to do with climate change? Well, the warmer the air, the warmer the water, and I'll show you how that relates. And the warmer the water, the stronger the storms in general. And these storms can devastate land areas that they go over. This is Maria as it was crossing over Puerto Rico a few years ago. You can see how much bigger that storm was than the landmass, the island it was moving over. And of course, we all saw the pictures. It wrecked large portions of Puerto Rico and displaced people and so on. It was a real humanitarian disaster. Another thing they can do is their storm surge can cause erosion along the beach and wash out roads. And I think this is on the Outer Banks of the Carolinas, but I'm not sure. But a similar sort of thing can be found in a lot of places. Now, another thing that a hurricane can do is pick up a lot of water and carry it because the air is warm. Hurricane Harvey, which hit and flooded Houston not too long ago, a couple of years ago, same year as Maria, I think. Anyway, carried a huge amount of water. And the amount of water that was dumped on the Houston metro area, which is drawn to scale here at the bottom, that bubble, you can see about half of that bubble, 27 trillion gallons of water, that was released as rain over the Houston metro area over the course of a few days. Now, there's another kind of cyclonic storm that we have up here in the Northeast called nor'easters. They're different in that the center of the storm is not warm, it's cold, and the fueling of the storm itself is not exactly due to heat, but the contrast of hot air all over the ocean interacting with cold air on land. And these, of course, for those of us who live in New England, we're familiar with nor'easters. They can produce an awful lot of precipitation because you're taking this moist air that is being pulled as it spins, in that counterclockwise way, and brings out that really moist air over the land. When it hits the land or hits the air over the land, it cools drastically and precipitates out, and you have a lot of rain or snow. Okay, another form of cyclonic storm. Again, the higher the contrast in temperatures between the ocean and the land air masses, the more precipitation and more strength that storm's going to have, as my understanding goes. And so you'll often have rain right at the coast and heavy snow inland. All right, now, the next topic, going back to our 2021 map, I think we're going to start talking about, let's see what's next. Oh, the amount of heat which is being trapped by greenhouse gases and what happens to it. Well, we have all this greenhouse gas, and everything from water vapor, which is a weak molecule for molecule, a weak greenhouse gas, but there's so much of it that it has a big effect. CO2, methane, and so on, all of which are trapping extra heat in the atmosphere. Where does that heat go? Well, 93% of it goes into the oceans. Cold water tends to sponge up heat, and that's where it goes. Okay, and the amount that has been trapped in the ocean over the last 50 years has increased noticeably. Now, there's two things that can happen that will relate to sea level rise by this warm water trapped in the ocean. One is, and this is something you can demonstrate in your kitchen if you're so inclined, you take water and you warm it up, and the molecules start vibrating faster and they get farther apart, and the water will expand, take up more room. Do that in a glass of water. Take some cold water and mark on the glass where the water level is and when it's cold, and then you let it warm up, and you'll notice that it's higher after it warms up. So warm ocean water in the ocean that is getting warmer will take up more space, therefore it's sea level rise. That's one thing. The second way that sea level can rise related to climate change is ice melt. Again, warmer ice that's in contact with, pardon me, warmer water contact with ice is going to melt the ice. The ice is going to go from solid to liquid, and sea level will go up in measurable ways. Now, where does that ice come from, you ask? Well, if you have a landmass, let's say Antarctica or Greenland, that are cold, and you have snow falling on that interior portions of that landmass year after year after year after year, and let's stipulate that there is more snowing, precipitation falling year after year than there is rain or there is evaporation, then the snow is going to build up, and successive layers of more snow on top of the previous snow is going to compact the snow. And if you get enough snow above, that snow will be compacted into ice, with very little else in it. You'll see a few bubbles of air, which are useful to scientists because then they can analyze that bubble of air and see what the atmosphere was like at that year when that ice was formed. But that ice forms these big ice sheets. Back in the last ice age, up to 20,000 years ago or so, there was ice that was a mile thick where we are right now, extending all over the pole and all the way down to Long Island. Now the big chunks of ice, there's some little chunks up on the mountains, alpine glaciers, but the big chunks are in Greenland, which is the last piece of the last ice age, and Antarctica, which is the really big chunk. Ice flows. If you give it enough time, ice will flow downhill just like water will. And when it reaches the edge of a continent or an edge of a landmass, it extends out over that water, forming an ice shelf. And we'll talk about that more in a bit. So let's see. There we go. Now, when that ice, going back here a second, extends out, it'll break off eventually. And when it does, it forms chunks of ice floating around, icebergs. And that's what we call sea ice, ice that is floating around on the ocean. And some of it is formed by Greenland and Antarctica. Some of it's formed by the Arctic ice sheet, which is not anchored to land at all, at least not very much. If you were to drill a hole in the North Pole, you would hit water long before you would hit terra firma, the bottom. Not so Antarctica, but the Arctic is that way. And so the amount of this ice that's floating around running into ocean liners in 1912 or whatever is of some note. And a lot of evidence has been collected, a lot of measurements have been collected about how much this stuff is, and there isn't as much as there used to be. All right, now climate scientists and ecologists like me who study climate are interested in rapid changes that might occur, where we may shift from one equilibrium state to a different equilibrium state. And that is what we call a tipping point. It's sort of like if you can imagine a glass, my water cup, imagine it was sitting on a table and I was tipping it to the top, and for quite a long time I could tip that cup and nothing would spill out, but eventually it would go clunk on its side and water would come out. Okay, that tipping point is the point where it goes from mostly standing up to falling sideways, spilling the water. Okay, it's a rapid change. So there's a couple of tipping points, climate tipping points that we are related to this. We want to look out after. One is the disappearance of the Arctic sea ice in the summer. There will come a time when there is so little sea ice at the North Pole during the summer that you'll be able to drive a ship there, a more or less ordinary ship there. You could paddle your kayak there, okay? That's not yet, but it will probably be in the lifetime of my grandson, who's 4 years old right now. Okay, and it may be in the lifetime of some of you younger folks. Right, that is a tipping point, because at the point where there is not ice to reflect the sun's light back up into space, the oceans are going to start sucking up more heat than they have up till now, and all those things related to ocean heat are going to speed up, and that's bad news. A tipping point. All right, Greenland. Greenland's an island. It is got so much ice on it that the bedrock is compressed underneath the ice sheet. If you were to like pick up the edge of the ice sheet, look underneath it, there would be a cavity, not a cavity, but a low point underneath the ice that would be below sea level. Now, what happens in Greenland, and not as much in Antarctica, but maybe along the edges, is during the summer, the surface of the ice melts at the top of the ice, forming lakes. Those lakes will then, the water in the lake will find any old crack in the ice and enlarge it and form chimneys that go all the way down to the bedrock. That's called a moulin. Okay? And these moulins can be quite large and can empty a lake out in a matter of just a few hours, these temporary ice lakes. And so here's a lake, the edge of a lake on the surface of Greenland. Here is a moulin, a big hole in the ice that is melted by liquid water, and you can see the water flowing into it. Now, also notice that the surface of the ice looks dirty. It's because all the year there is dust and soot from our industrial activities, which are deposited on the surface of that ice. And dirty ice is not as reflective. And so having this soot on the ice speeds up the rate at which it melts, because the albedo is lower, the reflectivity is lower, so it's absorbing more. Okay, so the more gunk we put in the atmosphere, dust and soot and so on, the faster that ice will melt. Now, if you're interested, if you were to take the whole ice mass of Greenland and melt it, which would take quite a while, it would raise sea level over 24 feet. Now, another thing that's important about Greenland, I need to set up by talking about ocean currents. The ocean currents are the ocean is in motion, which is kind of meant to be a rhyme, but not really. And there is a set of currents that are going along the surface, and then there is sets of currents that are going down at depth. Those are in blue. And what's driving the current is differences in water density, which have to do with how salty the water is in different places and how warm or cold it is. Cold water is more dense than warm water is. And also the location of the land masses and the spin of the earth will help to steer where these currents are. And as you know, there is a current that at the surface runs a circle in the North Atlantic, goes up the coast of North America, over to Europe, south to West Africa, and then west to the Caribbean, and then up to coast of North America again. All right. That's has been called the Gulf Stream. It's also, scientists call it the Atlantic Meridional Overturning Circulation, the AMOC. Anyway, these currents are massively important on distribution of heat through the world. All right, notice this blue blob south of Greenland. That is a blob of cold water, which is present most years from the melting of the ice on Greenland, and the fact that ice melt is fresh water, not salt water. All right, so it's at the surface and it's cold. Now, why that's important is this Gulf Stream that you can see the surface current in orange here goes right very near that. And when that blue blob is large and well developed, it slows up the transport of heat from the tropical Americas up to Europe. Have you ever wondered why there's islands in Scotland that have palm trees growing on them? It's because of all the heat of the ocean sweeping up towards them. Okay, those palm trees aren't native; they're imported, but nonetheless, there they are. And it's also why Ireland and England are rainy and not as cold as you might expect from the latitude, and why southern Norway and Sweden and Denmark are so rainy. Same thing. It's all that warm water coming up by the ocean. But if that water is not moving as fast, then that heat is staying nearer to us, and we are likely to find that as the world warms, Western Europe might actually cool a lot, and where we live might warm up extra because that heat that generally goes up to them is staying here longer. Okay, now Antarctica, that's the big ice box. Antarctica wasn't always cold. It used to be in different locations around the earth, and there are fossil forests there and dinosaur bones and things like that from years past. But now it's as cold as any place in the coldest we have. And the South Pole itself is like right in the middle of that circle. And the smaller West Antarctica and the larger East Antarctica are named arbitrarily because if you're at the South Pole, which way is east? Anyway, you can look along the edges of the continent, and it is a continent, and it's a very high altitude continent. And you can see that there are areas where these are ice shelves that are flowing toward the coast, and they're flowing out over the ocean, where some of those areas that are coated in blue are gaining ice a little. You notice that the rate of thickness change is 0 to 10 on the scale up there. And those in red are losing ice. And you notice that scale is 0 to minus 25. And so the amplitude of the losing is far greater than the gaining. If you added it all up, you have a mass loss from Antarctica. But nonetheless, West Antarctica is losing more mass than East Antarctica because it's lower elevation and it's more in contact with the ocean, and it's smaller. And there's volcanoes underneath some of the ice, but they haven't erupted in a while. Now, so this ice that, you know, has formed over thousands of years will gradually, slowly, cold ice flows slower than warm ice does. And as the ice warms up, it moves faster, moves toward the edge of the ocean. And at some point it loses contact with the ice loses contact with the land, the bottom of the ocean underneath it. And then it extends out and becomes a ice shelf. At that point, you've got warming water coming underneath it that are melting it from below. You have warming air above it, warming it from above. And so you have a double extra amount of warming that is thinning that ice. And so it is more likely to break apart. Also, if you lose a big chunk of ice shelf, then that ice shelf acts as a kind of a cork in the bottle for the ice flow behind it. And an intact ice shelf slows the speed of the ice behind it. So if the ice shelf breaks up, the cork is gone and the ice sheet behind it can move more quickly, relatively. All right, here are some of the big ice sheets, sheets in Antarctica that look like little countries or so on. And they're color coded by how stable they are. Those in blue are less likely to break up. Those in red are the most likely to break up, and those in yellow and orange are in between. Okay, now look on the west side of Antarctica here. You see one that is particularly pink. That is the Thwaites Glacier. Write it down because you're going to remember that name because you're going to hear it a lot in years to come. Right above it, to the well, I don't know if you call that north, but there's a dark orange one just next to it. That's the Pine Island Glacier. And both of those glaciers are showing signs of disintegration. That's concerning because that is telling us that something is going on faster than we had anticipated, faster than it did a few decades ago. And it's quite likely that over the next few years, maybe while I'm still a professor at WestCon, that Thwaites will break up the shelf. As it does, the glacier ice behind it will speed up and it will cause an increase in ice moving into the ocean and increase in sea level rise. If that whole mess, that whole pink area were to go, and it's like the size of Florida, and it would take a while, it would probably increase sea level by about 2 feet. Okay, Pine Island likewise. Okay, but it will then speed up what's behind it. Right, and so here's the edge of Thwaites Glacier, and you can see the edge of it beginning to crumble. It's beginning to crumble because it's in contact with warmer water and warmer air, which make it less strong. In fact, if we look at the amount of gain or loss in Antarctica in the blue and Greenland in the orange or brown or whatever that is, we can see that they are both losing mass just over the last couple of decades. Greenland is losing it faster because it is in a warmer ocean than Antarctica is, but Antarctica is a more drastic thing because there's a lot more water there and a lot more potential sea level rise. And so another tipping point is that acceleration of ice loss from Greenland and Antarctic ice sheets are likely to increase sea level up to 2 meters per century in the future, and not so distant future either. Now, 2 meters, 6 feet per century. That doesn't sound like very much considering the age humans, how long humans are usually around, but think of it. Oh, and if the total melt of West Antarctica would raise sea level by about another 10 feet. That's just Western Antarctica. If you melted West Antarctica, Greenland, and East Antarctica totally, if you could do that, you would raise sea level up to about the chest on the Statue of Liberty. That's a lot of water. Now, then this happened, March 18th, something that no one expected, no one had even considered plausible or likely. And that was for a big heat dome to set up on East Antarctica, raising the temperature of that surface 40 degrees past what its average it was, much higher than we had ever measured it. 40 degrees Celsius. Okay, it's like 70 degrees Fahrenheit. It is usually cold as cold can be in interior East Antarctica. It was not quite as cold as that. It wasn't exactly, ice melt, but it was going to set a pulse of heat down through the ice, which who knows what effect it will have. We just don't know. Also notice, I don't know if you can notice, but the big blob there, if you look to the west of that, to the left of that, where it reaches the sea, there was a lot of heat sitting right over those two glaciers that we consider to be really in bad shape. And so that didn't help them either. Imagine southern Florida after a few feet of sea level rise. Imagine southern Bangladesh after a few feet of sea level rise. There are 17 million people in Bangladesh, poor folk, not people who can afford to get up and relocate to Miami. But 17 million people who are right at subsistence level economics that live within a meter of sea level in the Sundarbans, this big delta formed by the Ganges and Brahmaputra rivers. Talking about human loss, they have nothing and they'll lose what they have under those circumstances. And where do they go? It's not only them. I mean, there are cities that are, inches above sea level, like Bangkok and Shanghai and Jakarta and Lagos, Nigeria, and Alexandria, Egypt, and Miami and New Orleans, and you can keep going. Asian cities, generally speaking, will be the worst hit, largely because they have large populations. And Shanghai, the highest of all. Shanghai, big monster city, just a huge city, biggest city in the world, and it is very vulnerable to sea level rise. Rio De Janeiro is the city in South America that is the most vulnerable. Not only is it near sea level, but it has a large population. Miami is the most vulnerable in North America, The Hague in the Netherlands, in Europe, Alexandria in Africa, and there are island nations in Indian Ocean and Pacific that will cease to exist. Entire countries gone. Just a few, less than a century. So the future that we have ahead of us, and we have to face it, and we have to face it with humanity, is hundreds of millions of climate refugees, and we are starting to see them now. We had climate refugees back in the 30s when the Dust Bowl Lokis had to move to California and were not treated well once they got there, all of them. Climate refugees, Americans that were kept from getting into California because there were too many people there already, So we're going to face it, and we're going to have to deal with it, and we're going to have to live with it. Okay, could I answer any questions? I'd be happy to try. If I don't know the answer, I will tell you.
Yeah, if anyone has any questions, you may want to just type it in the chat. I can relate it to Mitch.
Probably read the chat myself too.
Of course, yeah.
If I can find the, I always lose the screen here. That no.
Oh, quick question to everyone. Is
Yeah.
everyone from the Danbury area? Is anyone out of state joining us today?
We're just curious more than anything else. There we go. What about effects of disease causing organisms? That's a
It's a
question.
big one.
That's
That's a
good
big
question.
question.
Yeah. I mean, there are a number of diseases can be spread in a variety of different ways. There are insect-borne diseases like mosquitoes that will become more common with more freshwater pools for them to breed in. There's also infectious diseases that are waterborne. Cholera is a good comes to mind. And if you have flooding that floods out septic systems and polluting that water with human waste, then cholera and dysentery and other things could very well show up. Yeah, I can imagine how that will be in large cities in the tropics, Lagos, Nigeria, for instance, or Bangkok, Thailand, where they just, I mean, they're right at sea level, and whatever septic systems they have are probably not, I would guess that they probably would be vulnerable to that kind of flooding. And throw in a good storm now and then, and yeah. Water wars in terms of Carl's asking about water wars in terms of freshwater potable water. If you have, one of the things that could happen in southern Florida, and if it can happen in southern Florida, it can happen other places, is the aquifers that are partially empty by pumping for domestic water and for agriculture and for golf courses and whatnot. Okay, empty out those aquifers, which allows saltwater intrusion. Okay, saltwater intrusion then is likely to make water which is currently potable not potable in the future, or could be used for certain things but not others. Yeah, so it's possible that those areas that are dry will, if they become more dry, then where is the water coming from? Who is getting access to that water? Is it going to go for growing crops for export? Or is it going to go for giving people drinking water and allowing them to grow the crops for their local consumption? That's going to be a big deal. Yeah. What's the next one?
We had one right above. What would you expect sea level to rise over the next 2 decades?
I mean, I don't really know that for sure. I think it's quite likely over 2 decades we could have a foot.
Ugh.
But I can't say that with any certainty. That is because there are just so many possible turning points that sneak up on you. There are other things that we cannot necessarily foretell easily. Someone once asked a character in a Hemingway novel, this is relevant, trust me, what he can say about going broke, and the character said, you do it gradually and then suddenly. Okay, what we're seeing is changes that has been gradual that are now becoming sudden. What we see is non-linear change, and that non-linear change means that the time we think we have may be shorter than we would like for everything that we've got to deal with. Yeah, so I don't really know for sure, but it's going to start, and it'll start faster some areas than others if Thwaites and Pine Island glaciers fall into the sea. Oddly enough, that ice entering the sea in Antarctica is going to show up as sea level in the northern hemisphere first due to some weird gravity things. So yeah. I wouldn't invest in oceanfront property. Just saying. You know,
Be better to invest in lakefront property.
maybe, I don't know. Yeah.
Oh, another question. Is there anything being done to address the rising sea level in these particular vulnerable cities like The Hague and Miami and Shanghai?
Let's contrast Jakarta, Indonesia with Bangkok, Thailand. I spent a year in Thailand when I was a kid back in the 70s. I was an exchange student. And I spent, probably 3 months in Bangkok of that year. Bangkok is right at sea level, and it's on subsiding land. They've overbuilt it, and they've overpumped the aquifers, and the ground is sinking at the same time the sea level's coming up. And they have 10 million people they're going to need to move in a big hurry, but they're not even doing it. They're not even willing to talk about it, last I heard, because that would be bad for business. And so let's wait until the very last second, and then it's a big panic. So imagine the human suffering comes from trying to quickly move 10 million people to higher ground. Okay, contrast that with Jakarta, which is also right, it's on the shore of the island of Java, and it is flooding all the time. And the Indonesian government has already started to make plans for building a new capital city on Borneo, which is on another island to the northeast, which is higher elevation, which is bad for some reason because Borneo is rainforest and orangutans and all that. But Indonesia is at least talking about moving and taking steps to move away from a vulnerable location. Doesn't mean they'll do it in time, but we'll see. At least they're talking about it. I have a friend of mine who lives in the Netherlands. She's actually from Wilton, Connecticut. She was in Thailand in my group, and that's how I know her. But she lives in Netherlands and has most of her adult life. And I have a standing suggestion that the first time she sees the Dutch start panicking about sea level, that she let me know. I haven't heard it yet, because I figure if the Dutch get panicky, then it's going to hit the fan, because the Dutch are really good at dealing with sea level, insofar as anyone is.
Is there any possible technological answer, like the Dutch, their engineering
walls? Yeah. Well, you can build. Well, Venice is one of those cities that's going to be vulnerable too, although it's in the Mediterranean, which is kind of a lake. Where it's only got one small outlet to the rest of the oceans, but they've built these big sea gates, floodgates around. It doesn't sound like a very practical solution to me, but I'm not an engineer, so I can't really say for sure. Yeah, I don't know. I think moving is the best thing to do. Or there are other plans. I mean, there are floating, there are redesigning cities to build in flood resistant landscapes like salt marshes and stuff, and build canals for drains and things like that. It's all good to plan. I don't know what of it is going to be successful or not.
I would say, let's support a lot of, STEM programs, especially for kids nowadays, because they're the ones that are going to be solving a lot of these problems, and
That's the
they
way I see
have
it.
no choice.
I mean, honestly, one of the reasons I do this, and do this as much as I do, besides it, I find it enjoyable, but I do it because it's what I can do, it's what I can do to give our kids and grandkids a fighting chance. I have a 4-year-old grandson. I can't imagine, years from now, if he doesn't think granddad did all he could.
Yeah. Well, you're certainly leading by example, and hopefully, a lot more of us can be like that to the younger generation, and they can see that there's a problem, and they know, the younger, kids, they know
They
what's
get it.
coming. They
Yeah.
know, and they're actually doing stuff about it. But a lot of it would have to come from an engineering technological standpoint. And hopefully, we will have some countermeasures in place the next decade or two.
Yeah, it's not just this, it's like a lot of things. So
Oh,
it's,
yeah.
it's going to be a mess. It really is. We just need to make sure it's less of a mess than it could be.
One more question. What is known about the future sun changes that may affect our Earth?
Well, the Earth does have, the sun does have cycles. It has a magnetic sphere. It has larger amplitude cycles, which are long and relatively unpredictable. It has shorter, shallower cycles that go every 11 years. And there's also always the possibility of a big monster storm that would send a bunch of radioactivity and ions our way that would cause a lot of damage. So there is variability there. And there have been events in the past in human history that correlated with low points in solar activity, but they're unpredictable. We don't know when those things are going to happen. And they're not responsible for the warming right now. Because if it were not for greenhouse gases, we would be actually in a slow movement in a cooling phase right now.
Anyone have any more questions? One more for Dr. Wagener before we sign off for this evening.
Recommended readings. Let me compile a list of good books that I think are useful, and I'll give them to Aurelio, and maybe he can post them somewhere. But yeah, that's a good thing. After all, you're a library, right?
Exactly. And if we don't have it here, we could find it from some other library through our interlibrary loan program. So don't be afraid if we don't find it in our catalog. Please use the interlibrary loan program, and we can find it, that title, from another library, and we will get it to you.
I'll put together a list of 5 or 6 books, and when everyone's read those, let me know, and I'll find some more.
Excellent, thank you. Just for everyone to know, this will be recorded and posted hopefully in the next 24 hours. Be sure to sign up for our next event, which is of course the last Monday in April, which is our last one, the Climate Hope. How do we fix this? So that is the last in our series for Earth in Crisis. And if you have any questions, feel free to email me, or feel free to email Dr. Mitch Wagener. I'm sure we'll answer any of your questions. If you're we'll try. Exactly. That's the best we can do sometimes. But we look forward to seeing you all again next time, which is April 28th on Monday, same time, 5:30. And hopefully you all remain safe and well. And until next time, I bid you good night.